So hello, Bill. Nice having you here.
Yes, it's great being here.
This conference in Phoenix. And I have a question. So you're working on sustainable devices, and
Yes.
this is very interesting. I hope that in the future we will not have any waste anymore.
No,
so
that'd
this
be a
would
good
be
goal.
a good vision. So besides this, what do you see as hot topics in materials research and which have the most potential for technology and industries in the next few years?
Well, I think it's Materials Research Society, and so materials are really core to a lot of things that we do in sustainability, because you have to extract the resources, you have to process them into a useful form, produce them into a product. But one of the links I think that's missing a bit is what happens at the end of the first working life of the product. Some products go for a very long time, like cars are repaired. There's huge industries around them, but things like consumer electronics, there's still a long way to go. We have the Ross and WE objectives and directives that were intended to try to manage e-waste. But I don't think we should be managing e-waste. I think we should be using it to create other products. And that's a completely different kind of set of principles in terms of design, in terms of materials, in terms of construction, in terms of how you manage the product when it comes back.
Okay, so this future without waste, this would mean there will not be any waste bins. We will just bring it back to the shop, our old electronics, or how can we think about that?
Well, I think that it starts at the beginning of the design, and it starts with the materials that you choose to put into the design. I think a lot of engineers are so focused on meeting the initial specification and making the product work properly, which of course you must do. Mm-hmm. But they don't give much consideration to what happens to the product when the first owner is done with it. What if you really designed the product for 3 or 4 owners, for example, or to have a working life that's 10 times longer than what your current designs require? I mean, we have almost 7 billion people on this planet. There is a huge, available market, total available market for these devices, and things like smartphones and computers and hard drives are ubiquitous now. So, and there's a big desire for this technology. So if you designed it for a longer working life, and I know there are laws against planned obsolescence and things like that, but that's not really what I'm talking about. I'm talking about really designing products for a very long life. Because whenever you look at environmental assessments of products, you find that the real big energy impacts, the real big environmental impacts are at the beginning. It's in resource development and making the plastics and making the metals and recovering the ores and the mining. Once you have it in those form, the longer you can use it, it's always better for the environment. It'll win on every LCA you could possibly do, because it's just so resource intensive to produce them in the first place. We should have additional uses for them, right?
Okay, very good. So, giving the importance of innovation in industry, how do you weigh the role of applied and basic research inside and outside of the companies?
I think there's a very important place for basic research where you're doing fundamental, has never been done before, breaking the limits of technology and coming up with new materials. But same token, you also need to be looking at that research for how you will scale it and how you will take it into production. And one of my roles in my career has been to look at, I'm a chemist. I'm an inorganic chemist. So I do basic R&D, yes. Yeah. Working in an engineering company, sometimes interesting. But to look at the process in terms of how is it going to scale. Are the chemicals that are used in this process really environmentally friendly? Are they going to be friendly to the people working with them, to the people that are going to be manufacturing the products? What do those chemicals look like on their life cycle? Yeah, they're doing the job now, but what if you have 10,000 gallons of it sitting in a plant? Is it still going to be just as friendly as it's sitting in that beaker? So looking ahead, for example, if you're working on cadmium, cadmium is largely controlled by ROSE. You're probably not going to be introducing too many products with cadmium in them, unless you can get exemptions to the ROSE directive, which is hard to do these days. So you need to integrate the existing regulatory framework, existing concerns about chemicals, and try in the beginning to incorporate that in your thinking in terms of your research and development, because it will have to meet those hurdles later on. It will have to scale. It will have to be economic. the materials will have to be acceptable. And so I'm not saying you need to do a toxicology report on your new inorganic intermediate or something like that, but you need to be thinking in those terms about, all right, I'm making 5 grams of it now. What if I was trying to make 5,000 pounds? How would that really change my approach?
Okay, but I think also your approach of this reuse is enabling to use critical elements again in the future.
Absolutely, right. So there's actually an initiative we just got involved with INEMI in the Critical Materials Institute to try to reuse the magnets that are actually in hard drives, right? Because they're called rare earth for a reason. They are rare on the earth. And so if we could use those magnets as opposed to just shredding them and ending up in waste bin someplace, that would be a valuable resource reuse. Because a lot of energy and effort went into making the magnet in the first place. Can't we find another use for a magnet? I think so. Just have to have the will and the infrastructure to recover it in an economically efficient and effective way that doesn't pollute the environment. So there are critical components and there are critical materials that can be reused. And I worked in one of my things was coming up with recycled content plastic for cell phones. And the big challenge there was coming up with a supply chain that could actually provide this very highly engineered form of polycarbonate with 25% recycled content plastic in it. Meet the specs, make it just as good as existing plastic, only more friendly for the environment. And when you do that well, everyone wins. The consumers win, the waste ups win, the local municipalities win, people get products that work just as well, but are more materials conservative and better for the planet and for people.
That sounds very exciting, I think, for our future. So also when we are thinking about these interaction of basic and applied research with innovation, what are the regional differences or geographic differences in this approach? So industry here and maybe in Far East, is there any difference?
Well, I think if from an environmental perspective, there are profound differences because I think you want to use the resources that are locally available, whether you're making a hard drive in the Far East, for sale in the Far East or in the geographic United States. When it comes to end of life, you absolutely have to take regional considerations into effect. You're not going to be taking quote e-waste and shipping it to another continent and then trying to make something new out of it. You have to do your resource and materials development locally. Recycling is best done locally. Even growing food is best done locally, right? It's less transportation intensive, it's less resource intensive. And so you need to start thinking about establishing these centers of excellence for design and reuse and these long life materials to be within certain geographies. Because it just doesn't make sense to take cargo ships full of water bottles and ship them to another continent in order to be recycled into plastic again. And so there's opportunities in every region and every country for really optimizing the infrastructure to maximize the use of these resources, to the electronics that we're producing, to the hard drives that we have, and making fair environmental use of them, and keeping them out of landfills and keeping them in people's hands and keeping them productive.
Okay, thank you. So next question is on how important is the materials science and engineering community in enabling innovation in industry? So for example, this conference, what can we do to enable this innovation and breakthroughs in?
Well, something I've been hitting the drum on pretty hard is I think people are doing sustainability and don't even know it, right? They don't even know it. When you keep your car 10 years, it's very sustainable. Nobody labels it as such. You say, well, I've paid off the car. I'm just going to run it until the tires fall off. Or I hope you don't do that. You maintain it. But you are doing sustainability when you make that solar cell more energy efficient. That is sustainable. When you make that hard drive to consume 50% less energy when it's running on a continued basis, that is sustainability by its definition. When you take a hard drive that used to be this big and store 2 gigabytes, and now it's this big and it stores 10 terabytes, wow, that is material utilization and efficiency. That is sustainability. The engineer just said, well, I just designed the world's smallest hard drive and the world's thinnest hard drive and the world's most efficient hard drive from an energy standpoint. Well, there's some sustainability talking points there. And you've conserved resources, you've conserved energy, you can make more with less, you've done dematerialization. I mean, when people have a cell phone, their smartphones do as much as a large workstation used to. In fact, do a lot more than they used to. That's dematerialization, and it's their clock, it's their alarm clock, it's their calendar, it's their timekeeper, it's their email. You don't have letters flying all over the place and manuals and books. So you can really be sustainability and conserve. You can do this well in the constructs of technology, and you can be more efficient with technology if you apply it in the right way. And the materials question part of it, the materials have to be designed for this journey. You have to be very intentional about how you do this. You don't if you mix the wrong materials in the product, they'll be mixed when you're trying to make something else out of it. And it's very hard to separate them at that point. It's much better to not put them together in the first place. So if you understand those interactions, you can design for the next step. You can design for it to be easily disassembled. You can design for it to be easily made into something else.
So we need materials for dematerialization.
Yes, and reuse, absolutely.
Yes. It's a good point. And so do you have any ideas how we can improve this impact? How can we make sure for industry or for materials researchers that it is better to design materials which are more sustainable, and also the car industry, if you want to sell a lot of cars, but maybe to bring them to sell less cars which are more expensive but more sustainable. Exactly. Do you have any idea for that?
Well, I think this is a hard one, because I think you have to bring math to it. We all have our perceptions about what is better and what's truly not better. But when you develop that engineering plastic, you say, is it really better for the environment? Are there tools out there? And there are. There's life cycle analysis. It's a whole emerging science to really understand what the environmental impacts are, and what the life cycle impacts are at the beginning, at the end, and what the real benefit is for what you've done. I think you have to put it on a piece of paper, and you have to do the engineering, you have to do the math to show, yes, this really is more resource conservative, it's less resource intensive, it saves energy over the working life. I mean, these are big questions you ask, whether you're trying to deal with carbon capture, you know, and fuels. And I mean, how do you really go about doing this in a much better way that's fundamentally better? Do you make gasoline from ethanol because you have lots of corn, or do you use the corn to feed people? What is the best environmental solution? These are not easy engineering questions, and we're going to need our best minds working on them to develop answers that are the correct answers and that stand the test of time. And so that's why I'm excited to be at MRS and promoting sustainability and trying to get everybody to think, what am I doing that truly is sustainability? I just don't call it that today.
Okay, good. Thank you very much for this very interesting conversation.